On Proxima b, a planet that orbits Proxima Centauri, a red dwarf star only 4.2 light-years away from our own Sun, there have been some strange goings-on. For years, astronomers have been noticing strange signals coming from the planet. There is no consensus on what these signals could be, but there are a few theories. One is that they are evidence of alien life, perhaps a civilization that is more advanced than our own. Another possibility is that the signals are natural phenomena that we don't yet understand. But what exactly are these signals? Let's find out in today's video. On December 16, 2020, a signal was detected from the direction of Proxima Centauri, our nearest neighboring star. The initial analysis of the signal suggested that it might be an artificial construct and not just a natural phenomenon. This led to a great deal of excitement, as it would be the first time we had ever detected a signal from another civilization. However, further analysis revealed that the signal was likely just an echo of our own civilization. This is not unusual, as it is often the case with signals from other stars. The human race has always been fascinated by the stars and planets. For centuries, we have gazed at the night sky in wonder, imagining what might be out there. With the advent of powerful telescopes and spacecraft, we have been able to get a closer look at the planets and stars around us. And what we have found is that many of them seem to be very similar to our own planet Earth. One of the most obvious ways to tell if a planet is inhabited is to look for signs of artificial light. On our own planet, the glow from our cities is the most obvious indication that someone lives there. When seen from space, this light is very bright and easily noticeable. In recent years, there has been a growing number of scientists who believe that advanced civilizations might exist in other solar systems. However, the primary obstacle to detecting these civilizations is that our telescopes have not been powerful enough to observe them. Although next-generation telescopes may mitigate this issue, Proxima Centauri is one of the star systems being assessed for the presence of other civilizations. A recent study published in the Journal of Nature Astronomy has raised the likelihood of our ability to detect artificial light on Proxima b, a nearby exoplanet in the habitable zone. The study, which was conducted by a team of international astronomers, used data from the orbiting James Webb Space Telescope to simulate the conditions on Proxima b, and found that it is indeed possible to detect artificial light from the planet. This is a significant finding because it means that we may be able to find evidence of life on Proxima b in the future. The study also highlights the importance of new technology like the James Webb Space Telescope in our search for life beyond Earth. Now, the upcoming Large UV Optical IR Surveyor, LUVOIR, is a space-based observatory that will provide even more insights into the cosmos. It is one of the proposed missions for the European Space Agency's Cosmic Vision program, and it is also one of the focus points of a new study by a team of scientists from various institutions. The Large UV Optical IR Surveyor would be able to observe the universe in ultraviolet, optical, and infrared wavelengths. It would have a field of view that is 1,000 times larger than what is possible with the Hubble Space Telescope, and it would be able to detect objects that are up to 100 times fainter. The Large UV Optical IR Surveyor is still in the early stages of development, and it is unclear if it will be able to launch in 2035. Now, artificial lighting would be essential on a tidally locked planet orbiting a star on the permanent nighttime side in order to maintain a technological civilization, as Eliza Tabor at Stanford University and A.V. Loeb at Harvard University note. Without a day-night cycle, there would be no way to generate the energy necessary to power lights large enough to illuminate an entire planet. They go on to say that such a planet would need to be in a narrow orbit around its star in order to maintain the correct temperature for liquid water to exist on its surface. This combination of factors makes it very unlikely that a planet like this could support intelligent life. While the research is speculative, it does provide insight into the kinds of conditions that would be necessary for a planet to sustain a technological civilization. Scientists have long theorized about the possibility of life on other planets, and while there is no definitive proof that aliens exist, there are a few ways to identify the presence of alien technology on another planet. One way to look for alien technology is to look for signs of a technology that is far beyond our own. This could be things like a planet that has been artificially terraformed, or a planet with structures that are too large or too complex to be explainable by natural means. Another way to look for alien technology is to look for signs of a technology that is unfamiliar to us. This could be things like a planet with strange atmospheric conditions, or a planet with inexplicable geological features. Of course, the presence of alien technology on a planet does not necessarily mean that aliens exist, but it is one of the few ways that we can hope to find evidence of their existence. Artificial light is different from starlight in many ways. For one, artificial light is much brighter and easier to spot. Additionally, artificial light typically has a regular pattern, while starlight tends to be more random. Now, the James Webb Space Telescope, JWST, is a powerful instrument that will allow us to study the Proxima b planet in great detail. Proxima b is the only confirmed planet in the Proxima Centauri system and is 4.25 light-years away from Earth. Proxima b is a rocky planet located in the habitable region of Proxima Centauri, an M-class red dwarf star. Proxima b has a radius that is 1/3 the size of ours and about 1/6 the mass of Earth. It completes one orbit of Proxima Centauri in 11.2 days, traveling 7 million kilometers, or just 5% of the distance that Earth travels around the Sun. The study found that if the artificial light on Proxima b were as bright as 5% of the natural day-side illumination, Webb would be able to identify the light with an accuracy of 85%. If the artificial light were to reach 9%, Webb's accuracy would increase to 96%. The amount of light given off by Proxima b is substantial on a cosmic scale. However, only a tiny fraction of that light would be reflected by artificial lighting on Earth. In other words, a civilization on Proxima b would not be detectable by the Webb if it was as lit up as ours. If we want to find evidence of an extraterrestrial civilization, we may need to look for planets that are tidally locked. This means that one side of the planet is always facing the star, while the other side is in perpetual night. A planet like this would likely need a very bright lighting system, which we might be able to see from our telescopes. Of course, this is just a theory. However, research suggests that we may be able to find evidence of an extraterrestrial civilization using future telescopes like LUVOIR, or the Large UV Optical Infrared Surveyor. The ability to detect city lights on extrasolar planets is a game changer, said Thomas Beatty of the University of Tucson's Department of Astronomy. He has reviewed the LUVOIR and Habitable Observatory programs. He supports the researchers' findings that these telescopes will have the ability to detect city lights on planets that are orbiting stars up to 30 parsecs or PC away. He also said that with these telescopes, we'll be able to study the atmospheres of planets in greater detail than ever before, giving us a better understanding of what makes a planet habitable. The LUVOIR and Habitable Observatory programs are two of the most ambitious projects currently underway to study extrasolar planets. If successful, they will provide us with invaluable information about the habitability of planets around other stars. Now, what might be of interest is that the urban areas are often brighter than rural areas because of the concentration of artificial lights. However, when Beatty scaled the size of the planet based on its degree of urbanization, he found that the more urbanized an area, the brighter it appears. This is likely due to the fact that urban areas have more artificial lights than rural areas. While it is unlikely that there are any advanced civilizations close enough to us to be seen with a telescope, there is a possibility that we could see a faraway civilization more clearly if there were more people living in cities. For example, if the percentage of people living in urban areas increased by 100%, the city lights would be much brighter and more visible from a distance. However, it is important to note that this would not necessarily mean that the civilization was more advanced. It could simply mean that they had a higher population density. For this, we can utilize a term known as ecumenopolis, used to characterize a planet with a single gigantic city crossing its whole surface. This is hypothetical at this point, yet it is a captivating thought to consider. But what might such a planet resemble? Would it be a utopia or a dystopia? Only time will tell. So there you have it, guys. I hope you found this video interesting and informative. And if you have any questions or comments, I'd love to hear from you. Thanks for watching, and I'll see you in the next video.